All right, so in this video, we're going to take a look at variables, types, and data in Python and try to gain a better understanding of what these terms mean. So when we think about a variable, we're just thinking about a name, location, and memory used to refer to some data. So if we had this assignment statement here where we're assigning the value of 10 to x, this value or this data here, 10, exists somewhere in memory, and this x here, the variable x, also resides somewhere in memory. So let me discuss this in a little bit more in detail. So here we have the representation of this data in memory, the value of 10. And this value of 10 maybe resides at the memory location 600. So in Python, what a variable actually holds, like x, it just simply holds the address of this particular piece of data here. So it's actually referencing or referring to this particular piece of data. So say that we changed the value of x. We did something like this. We did the assignment of 20 to x. What would happen is wherever 20 resides in memory, so say it resides at the memory location 900, we would now have that particular value associated with this variable x. So x is just simply referring to this particular piece of data that resides at that particular memory location. So that's really what's going on when we do an assignment to a particular variable in Python. So again, the variables in Python just simply hold references to some particular data. So in terms of type, the type specifies the operations that can be performed on data and the possible values for that data. So data in Python is represented by objects, and I'm not going to go into a lot of detail in this particular video on objects, but when we think about objects, we need to think about things that have certain properties, certain attributes, and also the operations that we can have associated with that. So Python is what we call a dynamically typed language. And part of what that means is that values have type, but the variables do not. So here we can see that we have various types here on the right-hand side, like 5 is an int. It can be assigned to the variable x. 2.5 would be a float. So numbers that have a fractional part would be a floating point number. Those could be assigned to this variable x. We could have a string like hello, assign that to x, or we could have maybe a list. So lists are denoted by these square brackets and then some type of values separated by commas. So each one of these types that we have on the right-hand side have an associated set of operations. So depending on what x is actually referring to at any point in time, we can perform those operations. So in the case of the list, if x was referring to this list, we could sort that list if it was unsorted. In this case, it's sorted. We could reverse it, count the number of times a number appears in that list. We could remove a value from that list. We could append to that list. But those same set of operations that we can do on a list, we couldn't perform them on an int or a float or a string. And the same goes with these other data types. So in the case of the string, we could find a particular character. We could determine whether all the characters are digits. We could determine if all the characters are alphabetic characters. So those are operations that we couldn't do on a list, we couldn't do on a float, and we couldn't do on an int. Same thing with float and int. So if we wanted to do mathematical operations, we could do that here on x if it was an int, or x if it was referring to a float, but not in the case of it referring to a string. It just depends on what x is referring to. So what we're going to do now is go over to the PyScripter interpreter and just look at how we can retrieve the type associated with a variable. We can look at the identifier associated with a particular value that a variable references. So every time that we assign a particular value to a variable, that value has a particular identifier associated with it, and it's really just the memory location. At least that's the representation now in Python. That may change. And so let's go over there and take a look at all that. So we're over here inside the Python interpreter within PyScripter, and the first thing that I wanted to show you is how we can retrieve the type associated with any variable. So say that we did x assignment statement 10. We know that 10 is an int value, and we should assume that x is referring to an int, but we can confirm that by saying type open paren x, close paren, and that will actually return the type that x is referring to. If we were to say x assignment statement 2.5 and run the type operation again, or call the type function on x, we can see that the type for x now is a float. It's changed what it's referring to. Let me do one more. Say x is assigned to, or hello is assigned to the variable x. So this is a string. Then we can run the type operation again and see that, in fact, that is a string. So it's pretty neat to be able to retrieve the type that a particular variable refers to at any point in time in our program. Another thing that Python provides to us is this ID function. So we can get the ID of a particular variable, so ID open paren x close paren, and that just simply returns what x is actually holding, the reference that it's holding. More specific, this should be the actual address for this value hello, since that's what x is actually referring to. At least I think that's the case with the current implementation of Python, that this particular ID actually maps up to the address location of this value. Let's do something else. Let's say that x, we're going to assign it back to the value of 10 back to x, and then we'll say x plus 5. So we should be able to do that type of operation. So we're just taking 10, which is what x is referring to, and adding it to 5, and that's 15. But if we were to try to do that on a string, say that we assign the string hello back to x, and then try to do x plus 5, that's a problem. We don't know, this operation is not defined where we're trying to add or concatenate, in this particular case, int 5 to the string hello. So concatenation just means to join two things together. We don't know how to join the string hello to this integer 5, and that's why we get this error message here. Let's do something else. Let's say that x is referring to maybe a list, and a list is just simply a sequence of values separated by commas within square brackets. So we'll say that we have an integer list here where we have 5, 8, 24, 3, 0, and maybe -1. And we can do a lot of different operations on a list of values. One operation we can do is sort. So we can do x dot sort, open paren, close paren. And now if we were to say x again, we can see that that returns the sorted list. We could also do x dot reverse, and we could reverse that list. So if we now print out x, we can see that the list has now been reversed. So it all depends on what a variable is actually referring to, what type of data it is, determines what sort of operations we can actually do. The other thing that you should remember is that these particular values, these things, so a list, a string, a int, a float, they actually have a particular location out in memory, and that is, in fact, what the variable is referring to. So I think that concludes everything that I wanted to discuss in this particular video, and hopefully you have a little bit better understanding of variables, types, and data.